Hi guys, welcome to Cola Teaches Math. So today we're going to talk about 10.2 geometric series. We're going to move into all the different series tests for convergence and divergence. And there's a lot of memorizing involved here. So let's check out the rule. So if we have a geometric series that looks like this in this form, AR to the n is equal to k, it can look like AR to the n minus 1. It doesn't matter. Then we are going to diverge if the absolute value of r is greater than or equal to 1, and we are going to converge if the absolute value of r is going to be less than 1. And remember what r is. R is the common ratio. So r is the common ratio. It's like the pattern, not like the pattern, it is the pattern on how you're going from one term to the next. So if r is 2, you're multiplying by 2. If r is a half, you're dividing by 2. And a lot of the times these tests are really, really easy to spot. So if you go ahead and look at number 1, you can see that we have a series in the form AR to the n minus 1. So say you wanted to write out the first few terms just to see and understand. If we replace n with 0 right now, my first term is going to be 4. If we replace n with 1, it's going to be 4 times 1/4. If we replace n with 2, it's going to be 4 times 1/4 squared, and so forth. You can see that I'm multiplying by 1/4 over and over and over to go from one term to the next, which means r is going to be 1/4. You can also just spot it because it looks like the form AR to the n, so r is 1/4 right away. So now we're going to converge because the absolute value of r is less than 1, like that. So we converge by the geometric series test. So we converge by geometric series test. You want to make sure you say if you converge or diverge, which test you used, and you have to show the conditions of the test, which I did right here. I said the absolute value is less than 1. I identified r, and then I made my conclusion. Okay, so let's do that over and over and over. So, also I forgot to mention that if we converge